Can you solve this tricky geometry question asked in SAT entrance exam? We are given a semicircle, and inside it there is a large square positioned like this. The area of this square is 64 square units. To the right of it, there is a smaller square touching both the large square and the arc of the semicircle just like this. And our goal is to find the area of this smaller square. You can pause the video and take a moment to think about it, and when you're ready, you can come back to verify your answer. Alright, let us solve it together. We are told that the area of this large square is 64 square units. That means its side length must be the square root of 64, which is 8 units, right? Now let us assume that this point right here is the center of the semicircle. Since the square is 8 units wide, and the center of semicircle lies directly in the middle of its base. So this part is 4 units, and this other part is also 4 units. Now let's draw the radius from the center of the semicircle to the upper right corner of the large square, like this. Let's call this radius as r. Now look at this green triangle. The height of this triangle is 8 units, the base is 4 units, and the hypotenuse is r. Since this is a right-angled triangle, applying the Pythagorean theorem, we have r squared is equal to 8 squared plus 4 squared. That means r squared equals 64 plus 16, which gives us r squared equals 80. Let's keep this value of r squared here. Now let us assume this side length of the small square as x. Now focus on this new triangle formed by the radius and the side of the small square. The height of this triangle is x, the base is x plus 4, and the hypotenuse as r. Since this is also a right-angled triangle, applying the Pythagorean theorem one more time we get x squared plus the square of the quantity x plus 4 is equal to r squared. We already found that r squared is 80, so substituting that in, we get x squared plus the square of x plus 4 equals 80. Now expanding the squared term, we get x squared plus 8x plus 16 equals 80. Combining like terms, we get 2x squared plus 8x plus 16 equals 80. Now subtracting 80 from both sides, we have 2x squared plus 8x minus 64 equals 0. Now again dividing the entire equation by 2, we get x squared plus 4x minus 32 equals 0. This equation can be rewrite in factor form as x squared minus 4x plus 8 times minus 4 equals 0. Now taking the common term out, we get x minus 4 times x plus 8 equals 0. This gives us two possible solutions, x equals 4 or x equals negative 8. But since length cannot be negative, we discard the negative value. So the side length of the smaller square is 4 units. That means the area of this smaller square is 4 times 4, which is 16 square units. Pretty neat, right? But wait, before you go, I have a bonus challenge just for you. Can you find the area of this smaller square in terms of a variable x instead of a number? Think it through and drop your answer in the comments below. Let's see who can figure it out. If you enjoyed this explanation and learned something new, don't forget to hit that like button, share it with your friends, and subscribe for more fun brain-teasing math puzzles. Thanks so much for watching, and I will see you in the next video.